Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind, and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into the mysterious flicker of the stars, that gentle twinkling you've seen in the night sky. A shimmer so familiar it almost goes unnoticed is actually a beautiful illusion, a dance of light and air, physics and perception. But it's also more than that. The twinkle carries with it a kind of poetry, a connection across cultures and centuries, and a reflection of our own shifting thoughts and emotions. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into twinkling stars together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Imagine you're lying on your back in a quiet field. The grass is slightly cool beneath you, and the air smells like night. Just a trace of dew and leaves and something old and endless. Above, the sky stretches out like a deep velvet blanket scattered with tiny lights. Some shine steadily. Others shimmer and pulse, as if they're catching their breath or trying to whisper something across the distance. Those little flickers, those twinkles, aren't coming from the stars themselves. Out in the vacuum of space, light travels in straight, unwavering lines. It's only when it reaches the final few miles brushing past our restless atmosphere that it begins to dance. And so, the twinkle begins. Not because the star is flickering, but because the air around us is alive, with heat, with wind, with invisible motion. It bends the light just a little, then bends it again. And your eye catches that final story, this momentary wiggle in the sky, and turns it into something gentle and familiar. A flicker, a sparkle, a reminder that even in the vast, cold silence of the universe, something is moving, breathing, alive. Throughout this evening, we'll explore that flicker from every angle, the science behind it, the emotion it stirs, the ancient wonder and the modern technology, and most of all, the quiet connection it offers you, between the stars above, the air around, and the quiet place inside your own chest where wonder waits. So take another breath, deeper this time. Let the weight of the day fall away. The stars are waiting, and they're twinkling just for you. Let's stay here a little longer, just beneath that quiet sky. There's something timeless about watching the stars. You could be a child lying on the roof of your parents' house, or an ancient traveller tracing constellations as you cross the desert. You could be someone in a modern city, peeking up between buildings, finding the one or two stars that manage to shine through the haze of neon and exhaust. Wherever you are, whenever you are, the stars are there. They've always been there. And they're always twinkling, at least to our eyes. That shimmer, that flicker, it's called stellar scintillation, a beautiful name for a quiet illusion. The star's light isn't blinking or pulsing really. It's steady, constant, and true. But the path that light takes to reach you is not. It bends, it jiggles, it shifts, because our atmosphere is never still. The air above you is layered like a watercolour painting, each one brushed in with a different temperature, pressure, and motion. As starlight passes through these shifting layers, it refracts, meaning it bends. And because these bends aren't consistent, because the air is always moving, the position of the star's light keeps changing ever so slightly. Your eye interprets that motion as twinkling. Now think about that. The twinkle isn't from the star. It's from us, from our world, from our weather, our warmth, our turning sky. The illusion we see is a reflection of Earth's own restlessness. In space, Above the blur of our atmosphere, stars don't twinkle. Ask any astronaut and they'll tell you. The stars are pin sharp out there, unwavering, like tiny holes poked in the fabric of night. Beautiful, yes, but somehow less alive. The twinkle is ours, a shared experience between Earth and eye. That's why astronomers build observatories on mountaintops or even launch them into space. The less air between telescope and star, the less distortion. They want clarity, precision. But maybe down here, we don't always need perfect clarity. Maybe the twinkle is part of the charm. It's easy to forget in the stillness of watching the sky just how much is happening between you and that star. Air currents dancing, heat rising from rooftops, temperature layers flowing like invisible rivers. The light from a distant sun is performing a silent acrobatic act just to reach your gaze, and that's just the physical part. There's also what happens inside of you. That little breath you take when the stars first appear, the way you instinctively search for familiar shapes, Orion's belt, the Big Dipper, maybe even Venus shining steady nearby. The way the twinkle seems to match the flicker of a thought, or a memory, or a hope you didn't know you were holding. Because the night sky is more than an arrangement of gases burning at impossible distances. It's a mirror, and the twinkle is the moment you notice yourself in it. So tonight we'll travel gently through that. Shimmer. We'll talk about air and light, about history and hope, and we'll stay unhurried. Like starlight slowed down to a whisper, because in that whisper, in that flicker, there's a kind of peace. Let's follow it, together. Let's begin our exploration with the journey of starlight, an odyssey that begins far, far away in the heart of a star and ends right here in your eye. Imagine a single beam of starlight. It begins deep inside a burning sphere of gas, millions, sometimes billions, of light years from Earth. That light may have left its home before your ancestors were born, before your country existed, before even some of our mountains rose from the sea. It's ancient light, patient light. It streams outward through the vacuum of space, unbothered and unchanged. Space is quiet, you see. No winds, no currents, no weather, just emptiness and possibility. For most of its journey, starlight travels in perfect straight lines. A photon leaves its star and heads directly toward us with no detour, no twist, no flicker. But eventually that light reaches us, and things change. Because our planet wears a blanket of air, a thin, protective, shimmering atmosphere that hugs the Earth like a soft cocoon. It gives us breath. It shields us from harm. But it also does something peculiar to light. As starlight enters Earth's atmosphere, it begins to bend. Not dramatically. Not like a mirror bouncing a beam across the room, but subtly, repeatedly, over and over again. This bending is called refraction. It happens because the air near Earth's surface is not the same throughout. Some patches are warmer, some are cooler, some are dense, others thin. These changes in temperature and pressure cause the air to behave like a lens made of liquid glass, one that's always shifting. When starlight hits a warmer patch of air, it might bend slightly one way. Then it hits a cooler patch and bends again, just a little. These bends accumulate. The light that was once heading in a perfect line now dances slightly before it reaches your eye. And that tiny wobble, that's the twinkle. Now, you might wonder, why doesn't this happen during the day? Why don't we see the sun twinkle? But the sun is huge in the sky. Even though it's far away, it appears large to our eyes. It's a disk, not a point. So while its light is also refracted, those little wobbles cancel each other out. The sun may shimmer near the horizon at sunset, but it rarely twinkles. Stars, however, are different. From our point of view, they're just dots, tiny sharp points of light. Each wobble, each minuscule shift, isn't blurred across a wide surface. It's all concentrated into that single speck. So we see it. A flicker. A dance. So the next time you look up and see a star twinkling, remember the story it carries. That light has travelled for millennia in a perfect path, only to find itself dancing in the last few miles. It's as if Earth insists on leaving its own fingerprint on the cosmos, a soft, ever-changing signature made of warmth and motion. And your eye, gentle observer that it is, captures it. Not the true position of the star, not its unwavering light, but something a little more human, a little more alive, a shimmer filtered through home. Now let's slow things down even further and take a gentle look at the air itself. You can't see the air above you, not really, but you can feel it on your skin, hear it in the rustle of trees or the hum of a distant airplane. The atmosphere is always moving, always breathing in its own quiet way, and it is this invisible motion that turns the stars from steady beacons into flickering dancers. You can picture it, if you like, as a great ocean of air stretching upward from the surface of the Earth, layered, rippling, flowing in currents and eddies. The wind you feel at ground level is only the surface of something deeper, more complex. High above, there are layers of air stacked like transparent veils, each with its own temperature, humidity and motion. Warm air rises, cool air sinks. Pressure differences swirl them together in vast invisible tides. This constant mixing means that light, which would otherwise pass through in a smooth line, is instead bent and jostled like a rowboat in choppy waters. This is what scientists call atmospheric turbulence, and it's the true cause of that stellar twinkle. Let's use a simple image. Imagine looking up through a swimming pool, watching someone hold a flashlight above the surface. You see the light, but it wavers, doesn't it? The ripples in the water distort it. The beam bends, it flickers. Not because the light itself is moving, but because the water is. Now replace that pool with the sky, and the water with ever-shifting air. The result? Starlight wavers and flickers, just like that flashlight, because the window we're looking through is in constant restless motion. And these distortions aren't just random, they're affected by the density gradients in the air, small changes in how thick or thin the air is at a given moment. These differences bend the light slightly differently, changing the direction it reaches your eye by the tiniest fraction of a degree. That might not sound like much, but when the light source is a star, a tiny, far-away pinprick in the sky, even the smallest bend can shift it enough to make it flicker. If you could freeze time and look up through the atmosphere like an astronomer, you'd see the light from each star wriggling around in place, a barely visible jitter that gives rise to that magical sparkle. And if you watch long enough, you'll notice the twinkle isn't consistent. Sometimes it pulses gently, other times it flutters, erratic and lively. That's because the atmosphere isn't just one sheet of air, it's a dynamic, multi-layered quilt of motion. Some layers are calm, others turbulent. Some are heated by city lights or warm ground. Others are cooled by night breezes or high-altitude currents. These differences act like shifting panes of wavy glass, distorting the starlight differently from one second to the next. It's a quiet kind of chaos, a cosmic illusion born from the breath of our own world, and though it may sound like a flaw, a distortion that interrupts a star's perfect light, it's also a kind of signature, a reminder that we're not just passive observers, we're part of the system. The twinkle is Earth's fingerprint, stamped lightly on every point of light we see. So the next time you glance up and see a star dancing faintly in the sky, think of it as more than just a flicker. It's a collaboration, a moment of contact between something impossibly far and the air that surrounds you. A conversation in waves and whispers, playing out across the sky. Now that we've wandered gently through the physics of twinkling, let's look a little closer, because not all twinkles are alike. If you've ever spent time stargazing, you might have noticed something curious. Some stars seem to shimmer wildly, blinking in and out of brightness like glitter on moving water. Others stay relatively steady, their light pulsing only slightly, and as you follow a star toward the horizon, its twinkle often intensifies, flickering more rapidly, even changing colour. What's happening here? Let's begin with the horizon. When you look at a star high overhead, its light passes through a relatively short slice of atmosphere to reach your eyes. But near the horizon, that same starlight has to travel through a much longer stretch of air. Thicker, denser, and often more turbulent. It's like trying to peer through a dozen layers of gauze instead of just one. The result? More refraction, more distortion, more twinkle. It's one of the reasons why stars close to the horizon tend to flicker more, especially in warmer months, when the ground has been heated by the sun all day. The layers of air near the Earth's surface become wavy with heat, like the shimmer above asphalt on a hot afternoon. And just like that shimmer distorts the view of distant objects on the road, it also bends and jostles the light of stars low in the sky. Then there's the matter of colour. Have you ever noticed a star near the horizon flashing from red to blue to white and back again? That isn't your imagination. It's called chromatic scintillation, and it happens because light of different colours, or more accurately different wavelengths, bends by different amounts when it moves through air. Blue light, which has a shorter wavelength, is bent slightly more than red light. So as the air shifts and shimmers, the direction of that starlight changes unevenly for each colour. One moment, blue might reach your eye a bit more strongly. The next, red takes its turn. The result is a rapid, beautiful fluttering of colours, like the star is winking at you in rainbow flashes. And yet, not every star behaves this way. Some remain strangely still, glowing with a steady light. Why? The answer lies in brightness, position, and atmospheric conditions. Brighter stars are more noticeable to our eyes, so their flickering tends to stand out more clearly. Dimmer stars, even if they twinkle just as much, might seem steadier simply because the changes are harder to see. Atmospheric steadiness, what astronomers call good seeing, also plays a role. On calm, dry nights, with little wind or temperature change, the air is more stable. Twinkling becomes softer, less dramatic. But on nights with gusts of wind, shifting pressure, or layers of warm and cool air tangled together, the stars seem to dance. Even your altitude matters. At higher elevations, on mountaintops for example, you're looking through less atmosphere, fewer layers, less distortion. That's why observatories are placed far above sea level, where the twinkle is diminished and the stars shine clearer. And let's not forget humidity. Moisture in the air scatters light differently than dry air. When humidity is high, twinkling can become fuzzier, more diffuse. In contrast, cold, dry air often produces the sharpest, most noticeable flicker. So, not all twinkles are equal. Some are quick and sharp, like a laugh. Others are slow and subtle, like a breath. Some stars change colour, others stay monochrome, but each flicker is a fingerprint, a signature of the air above you, the position of the star and even the night itself. It's one of the quiet delights of stargazing. The more you look, the more you notice, and the more you notice, the more personal the sky becomes. The stars may be far away, but their twinkle is shaped by everything close, your world, your weather, your presence in that moment of looking. Now that we've seen how stars shimmer and dance their way into our eyes, you might start to notice something odd the next time you step outside at night. Not everything in the sky twinkles. There's that one bright spot low on the horizon, steady, glowing, unblinking. Maybe you've even mistaken it for a star, but it's not. It's a planet. And unlike stars, planets almost never twinkle. Why is that? Well, it starts with a simple difference in size, but not the kind you might expect. Stars and planets are both points of light in our night sky, but the key difference is angular size, how big they appear to us from Earth, not how big they actually are. A star might be 1,000 times larger than a planet, but it's also light years farther away. In the sky, most stars appear as single-point sources, infinitesimal infinitesimally small beams of light. Their angular size is so tiny that when atmospheric turbulence jostles the light around, it creates noticeable changes in brightness and position. But planets are closer, much closer, and while they're still tiny from our point of view, they're not infinitely tiny. They take up just enough space in the sky that their light reaches us from a slightly broader angle. It's a subtle difference, but a powerful one. Because of this larger angular size, the light from a planet is less affected by small-scale distortions in the atmosphere. Those shimmering air currents that scatter a star's narrow beam barely nudge a planet's wider spread of light. The variations tend to cancel out. Where one bit of light might be bent to the left, another nearby is bent to the right. Together they blend into a steady glow. This is why planets shine rather than twinkle. They're still passing through the same atmosphere, the same shifting air, but their light has a built-in stabilizer. It's one of the best tricks for amateur stargazers. If you're ever unsure whether that bright point in the sky is a star or a planet, look closely. If it sparkles and shifts like a distant candle, it's likely a star. But if it glows with a calm, unwavering light, you're probably looking at a planet. Venus, for instance, often appears just after sunset or before sunrise. So bright it's sometimes called the evening star or morning star. But watch it closely. You'll notice its light is firm, constant, almost serene. And then there's Jupiter, Saturn, even Mars, each with its own slow, steady glow. They don't flicker, they keep watch. Of course, the atmosphere isn't always so kind. When planets are very low on the horizon, they might flicker a little. The same long path through thick air that makes stars twinkle more also affects planets, just not quite as dramatically. In rare conditions, especially during heat waves or in heavily polluted skies, even a planet's broader beam of light can waver. And then there are the objects that confuse us entirely: satellites, aircraft, even the International Space Station. These aren't stars or planets, but sometimes their movement and brightness play tricks on our perception. A slowly moving satellite might look like a wandering star. A plane, high and quiet, might seem like a flickering star at first, until it grows brighter, or blinks, or suddenly shifts course. Our eyes and brains are easily fooled by light in the dark. But the more we look, the more we learn to tell the difference. The flicker, the flutter, the glow. It all starts to make sense. In the end, it's a quiet reminder. Not everything that shines behaves the same way. Stars flicker because they are far. Planets shine steady because they are near. And we, standing between them, learn the sky by noticing how each one speaks. So far we've been gazing up with the naked eye, taking in the twinkling stars just as our ancestors did. But let's now shift our gaze, just slightly. Let's imagine you're peering through a telescope. Maybe it's one set up in your backyard, or maybe it's one of those enormous domed observatories perched high on a mountain. What happens to the twinkle then? Well, astronomers have a bit of a love-hate relationship with the atmosphere. On the one hand, it's essential for life. It gives us breath, shields us from harmful radiation, and offers that familiar blue daytime sky. But for those trying to study the stars in fine detail, the atmosphere can be a bit of a nuisance. Because remember, twinkling or scintillation is caused by the Earth's atmosphere. To get a clearer view of a star's light, you need to look through less of it. That's why so many observatories are built in remote elevated places, high mountains, dry deserts, or even on isolated islands. Locations like Mauna Kea in Hawaii, the Atacama Desert in Chile, or the Canary Islands off the coast of Africa. The air there is thinner, drier, and more stable. Less flicker, better focus, a crisper look at the sky. But even in those ideal places, the air still moves. And so scientists have come up with a clever solution: adaptive optics. Picture this. Inside a modern telescope is a mirror, not a solid fixed surface, but one that can flex and shift just a little. It bends in real time ever so subtly to correct for the wiggles introduced by the atmosphere, like a calm hand gently smoothing out ripples on a pond. The telescope detects how the starlight is being distorted, how the wavefronts of light are being nudged or tilted by turbulence, and then uses motors to adjust the shape of the mirror accordingly, sometimes hundreds of times per second. It's like giving the telescope a tiny pair of corrective glasses that updates constantly. The result? Stars that no longer twinkle, at least not to the telescope. To us, this feels almost magical. The technology quietly compensates for the shifting sky, restoring the starlight to something closer to what it truly is, still, distant and precise, a pure point in the dark. But of course, even the best adaptive optics have limits. That's why astronomers eventually turned to an even more elegant solution. They left the atmosphere behind entirely. In 1990, NASA launched the Hubble Space Telescope, an observatory in orbit, free from the shimmer and blur of air. Out there, above it all, stars don't twinkle. Their light arrives undisturbed, sharp and clean. And with it, we saw the universe in a way we never had before. Galaxies stretched across time, nebulae blooming with gas and dust, planets orbiting distant stars. It was as though we'd washed a window that had always been just a little foggy. More space telescopes have followed since then. James Webb, Chandra, Kepler, all giving us clearer and deeper views. But there's something poetic about that trade-off. We send machines into space to see the stars as they really are, but we stay behind here on Earth, watching them as they feel, flickering, imperfect, alive. It's not wrong, it's not broken, it's just different. Because in a way, the twinkle is a reminder that we're observing the cosmos from within a living, breathing world. We're not just spectators, we're participants, looking out through a lens that is shaped by our own sky, our own atmosphere, our own planet's breath. And sometimes that shimmer, however inconvenient it may be for a scientist, is the very thing that makes the stars feel near. Let's take a quiet leap now, from mountain peaks to orbit. Let's imagine ourselves floating just beyond Earth's breath, out where the air gives way to silence. Out here, in the vacuum of space, something curious happens. The stars stop twinkling. It's not that they disappear. In fact, they shine brighter and more steadily than ever before. But that playful flicker we're so used to, that lively dance of light we see from Earth, vanishes. The shimmer is gone. Why? Because the twinkle was never in the star. It was in the air. Without an atmosphere to bend and scatter the starlight, the journey from star to eye becomes direct, clean, straight, uninterrupted. The same light that began its journey light years ago now arrives in perfect form, unchanged in those final moments. No turbulence, no distortion. Just the star as it truly appears. Astronauts aboard the International Space Station have described this difference in soft, almost reverent tones. They say the stars seem still and piercing, pinpoints of brilliance, no flicker, just presence. It's a bit disorienting at first. We're so accustomed to the idea that stars should twinkle. It's woven into our language, our stories, our lullabies. But in space, the stars are steady. And in their steadiness, there's a different kind of wonder. A reminder that what we see from Earth is only one version of the truth. Beautiful, yes, but filtered through a moving lens. The Hubble Space Telescope, orbiting over 500 kilometers above Earth, has taken advantage of this clarity for decades. It's given us images so crisp, so delicate in detail, that they feel unreal. Swirling galaxies, the pale glow of nebulae, the thin rings of distant planets, all revealed because they were seen from beyond the atmospheric veil. This is what astronomers longed for, an unfiltered view of the universe, and it's why Hubble's successor, the James Webb Space Telescope, was sent even farther out, to a place called the second Lagrange point, where it floats in a cold, stable region of space, forever facing the deep night. There, stars still don't twinkle, not because they've changed, but because there's nothing left to interrupt them. Light uninterrupted becomes a straight conversation between past and present, between distant fusion and your patient gaze. But let's pause here a moment, because while it's true that the twinkle fades in space, what's left behind isn't lacking. It's just different. Less dreamlike, perhaps. More raw. More real. The twinkle, in a way, belongs to Earth. It's a signature of our sky, a product of our motion and warmth. It reminds us that we're inside something living, watching out. It's easy to forget when looking at distant stars that the very act of seeing is shaped by our world's breath. That shimmer is Earth's quiet participation in your stargazing. So while we can admire the stillness of stars from space and use it to study the universe with greater precision, it's okay to cherish the version we see from home too. Because down here, when the air's cool and the night is calm, the stars don't just shine, they speak, in pulses and flickers and colours that change from one second to the next. They shimmer like thoughts we almost remember, and that's something you don't get in a vacuum. You get that from being here, beneath a sky that isn't still, but alive. Let's take a slow breath now, and gently gather all the pieces we've explored so far. The twinkle of a star might seem like the smallest of things. A tiny flash in the corner of your eye, a momentary glimmer that's easy to miss. And yet, hidden within that flicker is a vast and beautiful story. It begins far away. Atoms fusing in the heart of a distant sun, light escaping through time and space, travelling unbothered through the emptiness of the universe. For millions of years that light glides forward, silent and constant until, just before it reaches your eyes, it encounters the atmosphere of our planet. And that's where everything changes. Our atmosphere, so thin compared to the Earth itself, is a restless ocean of motion. It breathes and flows. It carries warmth and weather. It shapes the path of the light not by intention, but simply by being alive. Air of different temperatures shifts and swirls. Layers of high and low pressure ripple invisibly above us, and the light, it dances. It bends this way and that, nudged by turbulence and heat. The narrow beams from a star, so sharp, so precise, are jostled just enough to shift the story they carry. By the time that light reaches your eye, it flickers and shimmers and glows in pulses. A star twinkles not because it wavers, but because we do. We watched how the twinkle is stronger near the horizon, where the light must pass through more atmosphere, more density, more movement. We noticed how colour changes join the dance, blue and red and white swapping places in a rainbow of randomness. We saw how humidity, temperature, even elevation can alter the way a star looks from one night to the next. Then we turned to the planets, closer, steadier, glowing with calm light. Their broader angular size softens the distortions, their presence more like a lantern than a flame. While the stars seem to flicker like thoughts, the planets keep their gaze, and from there we rose higher. We stood beside observatories on windswept mountaintops, watching astronomers use adaptive optics to tame the twinkle, to calm the chaos in real time. And when that wasn't enough, we floated with satellites, orbiting far above the breadth of the planet. Hubble, Webb, eyes in the silence where the stars shine without interruption. But even out there, in all that clarity, something is lost. The stars are steady, yes, but they no longer feel like companions in motion. The twinkle is gone, and that's when we return, back to the ground, back to the sky we know, and we realise twinkling is not a flaw in the system. It's a sign of where we are. It's our atmosphere's soft imprint on the universe, a reminder that we're not separate from the night sky, we're inside it. Twinkling is warmth, wind, breath, motion, Earth saying, I'm here too. So the next time you step outside and look up at the stars, take a moment. Let the flicker remind you not just of light and distance, but of connection. The star is far away. The air is all around. And you're in the middle of it, watching the cosmos through a lens that's uniquely yours. The stars may be silent, but through their shimmer, the night speaks. Let's begin this part of our journey with something soft, something familiar. You've likely heard it before, whether whispered in a nursery, sung by a parent, or hummed by a child gazing sleepily out a window. Twinkle, twinkle little star, how I wonder what you are. It's the first lullaby many of us learn, and curiously it may also be the first science question we ever ask. How I wonder what you are. That gentle curiosity wrapped in rhythm and rhyme is a kind of cosmic invitation, a moment where the mystery of the universe is folded into bedtime. It's comforting, isn't it? That even before we learn the names of constellations or the mechanics of light refraction, we're already looking up and wondering. We're already speaking to the stars, as if they might answer back. The poem itself is older than you might think. Written by English author Jane Taylor in the early 1800s, its original title was The Star. The melody it's paired with comes from a French tune. Simple, repeating, soothing. Over time, the pairing became a global lullaby, translated into dozens of languages and passed down from voice to voice, generation to generation, and at its core it remains unchanged. A child watches the stars, a flicker catches the eye, and a question forms. It's a beautiful reminder that science doesn't always begin with equipment or formulas. Often it begins with wonder, with noticing, with that little pause as a child sees something sparkle against the night and asks what it means. And here's something tender. The line about the star being like a diamond in the sky is not wrong, in a poetic sense at least. Diamonds shimmer because they bend light through many angles, through cuts and facets and polished edges. Stars, too, appear to shimmer because their light is bent, but not by their own shape. Instead, it's bent by the shape of our sky. So the comparison, though innocent and sweet, is unexpectedly apt. A twinkle is what happens when light meets complexity. In a diamond, that complexity is crystal. In the sky, it's turbulence. Either way, the result is a flicker of brilliance. And think about how this lullaby has travelled with us, through colonial empires, through global wars, through radios and televisions and smartphones. It still remains, spoken softly even now, in bedrooms and cribs across the world. It's no small thing, because in that repetition, those lines we know by heart, we find comfort, not just in the melody, but in the idea that the night sky is a shared companion. The same stars that glittered above Jane Taylor's window shimmer above yours, and above someone else's on the other side of the globe at this very moment. Twinkling becomes not just an observation, but a language, a memory, a pattern woven into our earlier sense of security. And maybe that's part of why the stars have always felt so close, even though they're impossibly far away, because they're introduced to us not with fear or distance, but with song, with gentleness, with bedtime breath. They enter our minds through the rhythm of sleep and settle there, quiet companions, always just outside the window. So the next time you hear that familiar tune, or hum it without thinking, let it bring you back, not to facts or figures, but to that earliest kind of curiosity, the soft, sleepy kind, the kind that wonders not because it needs an answer, but because it finds comfort in asking. There's something about a flickering light that draws us in. It's not just stars, candle flames, old film reels, the glint of light on water, they all have that same irregular, shifting glow, and somewhere deep in us, that glow awakens feeling. It softens thoughts, slows time. We don't just see the light, we feel it. That's what twinkling stars have done to us for centuries. Beyond the science, beyond the optics, the twinkle has always stirred something quieter, something emotional, romantic, even spiritual. Look at art, for instance. The most famous painting of the night sky, Starry Night by Vincent van Gogh, is not a technically accurate portrayal of the heavens. The stars in his swirling sky don't behave like real stars. They glow in thick strokes, almost vibrating with energy. But they're not just luminous. They're alive. They pulse. They move. They shimmer in a way we recognise not with our minds, but with our hearts. Van Gogh painted that scene from memory. He wasn't copying the sky. He was remembering how it made him feel. And in that feeling the stars were never still. Twinkle has become a visual language of wonder. It's how illustrators show enchantment, how films suggest magic, how poems describe longing. The flicker becomes a signal, not of something faulty, but of something beautiful. And it's not just visual art. Poetry, too, reaches for the stars whenever we try to express emotions too large for the room we're in. Think of Shakespeare. The stars are fire, the sun doth move. Or the way Sappho described stars as golden eyes blinking through the dark. Even modern love songs often mention the stars not as astrophysical entities, but as symbols of things distant, dazzling, and just out of reach. And why not? A steady light is reassuring, but a flickering one feels alive. A star that pulses seems to breathe. It responds, it changes like emotion, like memory, like love. There's a reason we say someone's eyes twinkle when they smile. We're not describing a physical shimmer, we're describing warmth, attention, that quiet sparkle that says, I see you and I'm glad. It's a metaphor, yes, but one born from sky watching, from the way we've always looked up and imagined stars returning our gaze. Romantic evenings are set under the stars not because they provide light, but because they evoke feeling. A rooftop date, a walk by a lake, a conversation where you pause to say, look at that one, it's twinkling. And suddenly, something unspoken passes between you. The twinkle holds that space. It says, this is fleeting, but beautiful. This is distant, but it matters. This is quiet, but it's shared. And perhaps that's what makes the flicker so tender. It doesn't demand attention, but it rewards it. You have to look for it, stay long enough to notice the change. It invites you to slow down. Science tells us why stars twinkle, but sentiment tells us why. We care. That flicker isn't just the product of turbulence, it's a companion to thought, a rhythm that matches the irregular beat of being human. So when we talk about romanticizing the stars, we're not indulging in fantasy. We're engaging in something deeply human, turning the cold mechanics of the sky into something warm enough to carry emotion. Because that's what we do. We take a distant point of light, thousands of years old, warped by the wind, and we say, that one makes me feel something. And it does. Let's shift our focus now, not upward, but inward. Because the story of twinkling doesn't end in the sky. It continues in you, in your eyes, in your brain, in the subtle ways your mind interprets what you see, and, more interestingly, how it feels about it. Your eyes are remarkable instruments. They receive photons, tiny packets of light, and turn them into signals, electrical pulses that travel through nerves into the dark chambers of your brain. But your brain doesn't just receive the information, it translates it, it edits, it guesses, it fills in the gaps. That means that when you look at a star, you're not simply seeing what's out there, you're also experiencing what your mind has decided to make of it. This is especially true with things like twinkling, because the actual changes in a star's light, caused by atmospheric turbulence, are extremely fast. Many of them occur dozens of times per second, some even faster than that. Your eye can't track each shift individually. Instead, your brain blends the flickers together into a feeling, a shimmer, a pulse, a sparkle that seems more fluid than it really is. In other words, your perception smooths the science. But it does more than smooth it. It colours it with meaning. The brain isn't just a neutral translator. It brings emotion into the picture. And light, especially flickering delicate light, tends to awaken something in us. We associate flicker with life, movement, awareness. Maybe it's because we evolved to notice changes in the environment, shadows in the forest, light between leaves, firelight on a cave wall. These tiny shifts became signals of presence, of warmth, of danger, of wonder. So even now when we see a star twinkle, something ancient stirs. It feels alive, present. And when we're feeling open, curious, quiet, reflective, we tend to see more twinkle. The brain becomes more receptive to the subtle shifts, more aware of those tiny dances in the dark. But here's something curious. When we're distracted, anxious, or overwhelmed, we might not see the flicker at all. The light is still dancing, but the mind is elsewhere. Twinkling then becomes not just an optical phenomenon, but a state of attention. And of course, the context matters. A lone star flickering on a crisp winter night feels different from that same star glimpsed through city haze while walking home after a long day. Your brain is always stitching together perception and emotion, what you see and how you feel about it. That's why stargazing feels different in different moods. It's why some nights the sky looks close, like a ceiling you could touch, and other nights it seems impossibly far away. Even physical factors come into play. As your eyes adjust to the dark, they become more sensitive to light. Tiny stars you didn't notice at first begin to appear. Flickers seem stronger. This adjustment takes time, about 20 to 30 minutes for full dark. Adaptation. During that time, your perception of twinkling shifts subtly and steadily as your body attunes to the night. So the twinkle isn't fixed. It's filtered through biology, shaped by thought, and gently painted with emotion. It's a reminder that the universe you see is never just out there. It's also in here, in your perception, your experience, your story. And that's not a distortion. That's part of the beauty. Light may travel for centuries to reach you, but it's your own mind that turns it into something meaningful, something moving, something luminous. So the next time you notice a flicker, pause for a moment. Not just to observe the star, but to notice the quiet theatre happening behind your eyes, the soft collaboration between photons and feelings, between what is seen and what is felt. Now let's drift a little farther, not in distance, but across time and cultures. Because long before we had telescopes or physics to explain the star's gentle flicker, we had stories. We looked up at the shimmering sky and filled it with meaning, messages, memories, myths. And that twinkle, it wasn't just a trick of the atmosphere, it was a sign, a signal, a voice from something beyond. For many indigenous cultures around the world, stars were not inanimate objects. They were alive, watching, speaking. Their flickering was interpreted not as random light, but as breath, movement, communication. In parts of Aboriginal Australia, twinkling stars were seen as ancestral beings moving or whispering in the sky. A fast twinkle might be a sign that a spirit was nearby, or that a message was being passed from one world to the next. These weren't metaphors, they were truths. The sky was not separate from life, but part of it, a kind of living map. Among the Inuit of the Arctic, stars were sometimes described as eyes, looking down, watching the movements of people below. In such remote and cold landscapes, the sky is especially clear, and the twinkle can be sharp and striking. It becomes easy to imagine each flicker as an intentional blink, a nod, a subtle response. In Polynesian cultures, master navigators learned to read not just the positions of stars but their behaviour. A steady star, a twinkling one, a red flicker near the horizon. Each variation became a piece of knowledge, a whisper of weather, a suggestion of direction. The twinkle wasn't a distraction, it was a tool. Many Native American traditions also wove twinkling into story. In some Cherokee tales, stars were campfires lit by ancestors on their way to the next world. The flickering was the flame itself, dancing and alive. And to the Lakota, certain stars were believed to pulse when carrying messages. Between spirits, between realms, between the past and the present. And then, of course, there were omens. In ancient Greece and Rome, a star's flicker could be seen as a warning. A flashing red shimmer on the horizon might mean war or an approaching storm. Astrology, long before becoming entertainment, was part science, part sky-reading intuition. The motion of the stars, real or perceived, was read like tea leaves scattered across the sky. In many of these traditions, what matters most is not why the star flickered, but what it meant. The act of watching was itself a relationship, a form of attention. The twinkle became a response, a sign that the cosmos was paying attention in return. And perhaps that's what all these stories share. The idea that the flicker is not random, but intentional. That somewhere in the shimmer, there's meaning. Even now, with all our scientific understanding, that idea still holds some quiet comfort. It feels good to imagine that the sky is not just something to study, but something to belong to. That when a star pulses softly in, the dark, it might be part of a story older than language, one still being told. So the next time you look up and see a flickering point of light, remember, someone else saw it too. A sailor crossing an open sea, a child in the desert, a parent singing a lullaby in a snow-covered tent. They watched that same twinkle, and in it they saw meaning. Let's now travel to the edge of history, before observatories, before charts, before anyone had a word for atmosphere. Even then, people were watching the stars, and they noticed the twinkle. They didn't call it refraction, of course. They didn't speak of photons or thermal gradients. But they watched, night after night. And from those flickering points of light, they began to build knowledge. In Babylon, over 2,000 years ago, astronomer priests climbed stone ziggurats to chart the motion of the heavens. They recorded the appearance of stars, the wanderings of planets, the dimming and brightening of celestial bodies, and when stars twinkled more than usual, when they shimmered near the horizon or flashed in odd colours, they made note of it. To them, it wasn't just a curious phenomenon. It was a form of communication, a signal that something in the world was shifting. Weather, politics, fortune. These observations weren't separate from daily life. They were daily life. Skywatching was part of agriculture, leadership, prophecy. The twinkle of a star could herald the rise of a king or the arrival of a storm. In ancient Egypt, astronomers watched Sirius, the brightest star in the sky, with special attention. Its annual reappearance in the pre-dawn sky coincided with the flooding of the Nile. But just before it fully emerged, it would flicker low on the horizon, red and gold and blue. The twinkle to them was not just beautiful, it was meaningful, a signal that life-giving waters were on their way. And in Greece, philosophers began to ask why stars twinkled while planets did not. Even without telescopes, their keen eyes noticed the difference. Ptolemy, writing in the 2nd century CE, speculated that twinkling had something to do with the stars' great distance. He was right in a way. The fact that they appeared as pinpoints meant their light was more easily distorted. Later, in Islamic astronomy during the medieval Golden Age, scholars in Baghdad, Damascus, and Cairo built upon Greek observations. They developed star catalogues and noticed patterns in twinkling that correlated with atmospheric changes. A rapid flicker, it might mean high winds or incoming storms, a steady glow. The air was calm. In a way, they were the first to use starlight as a kind of weather forecast. It's remarkable how much could be learned just by watching. No satellites, no data logs, just eyes, patience, and a sky full of shifting light. Tools eventually did come, astrolabes, sextants, and eventually telescopes. But for centuries the primary instrument was human perception. Sky watchers trained their eyes the way a musician trains their ear. They learned the personality of each star, how it flickered when it rose, what it foretold. To them the sky wasn't static, it was alive. And the twinkle, that was its breath. Even now, many of those early records still influence our understanding. Ancient sky charts have helped. Modern astronomers confirm long-term changes in star brightness. Myths that mention blinking stars have been traced back to real celestial events. History and science, it turns out, are not as separate as we often think. So as you look up tonight, consider this. You're part of a lineage, a long, unbroken chain of observers, people who stood just where you stand now, eyes raised, thoughts drifting, and watched a point of light shimmer in the dark. They didn't always know what it was, but they knew it mattered, and in their wonder they gave us the foundation we still stand on today. There's a particular kind of quiet that settles in when you're stargazing. Maybe you felt it, lying on your back in a field or sitting on a balcony with a blanket around your shoulders. The hum of daytime has faded, the world has gone soft around the edges, and above you flickers. The stars twinkle just as they always have. But tonight you're not looking for constellations. You're not trying to solve a mystery. You're just being there, with them. And somehow, in that stillness, the stars feel closer than ever. It's a strange truth of stargazing. The farther away the stars are, the more they remind us of something deeply personal, something intimate. They're not just distant suns, they're companions, quiet presences, and their gentle twinkle can feel like the softest acknowledgement, like a nod, like a breath that matches yours. For centuries people have looked up at the stars when they felt alone, in the stillness of exile, in the hush of longing, in the quiet ache of missing someone. The stars have been something to talk to, something to hold on to. There's comfort in the fact that they don't change, not in any way we can see. The same star that flickered above your head tonight likely shimmered above someone else's 1,000 years ago. A sailor at sea, a child in a snow-covered village, a poet lying awake in a city that no longer exists. And maybe that's why the flicker feels so comforting. It isn't a steady, impersonal glare. It's imperfect, alive. It moves. It feels like something that's trying to say, I see you too. Modern life doesn't offer many moments like this. Screens glow steadily. Notifications arrive with precision. Lights hum without variation. So when you step away from that and sit beneath the stars, where the light pulses and breathes, it feels different, more real, more forgiving. The twinkle isn't a flaw. It's an invitation. And you're not alone in feeling that. People all over the world, night after night, find themselves quietly pulled outside by something they can't quite name. They look up, they watch. Sometimes they sigh, sometimes they cry. Sometimes they just breathe more slowly. Because stargazing isn't always about curiosity, it's about comfort. It's a ritual of stillness, of connection. And the stars, those twinkling points of ancient light, seem to understand their role. They don't rush, they don't demand, they simply are. And in their being, they allow you to simply be too. It's no wonder that in moments of grief or reflection, we often turn our gaze upward. There's something reassuring about the stars continuing to twinkle, even when everything else feels uncertain. They remind us that the universe has a rhythm, that light endures, that the same sky arches over everyone. And when someone you love is far away or no longer here, you might find yourself thinking, they're under this sky too, or they once looked at this same star. And in that moment you feel held. not by answers or explanations, but by something quieter, something shared. So if you ever find yourself awake when the world is sleeping and the stars are blinking softly above, step outside or look out a window. Let your eyes adjust. Let your thoughts quiet. And know this: you're not the only one looking, and you're not the only one being seen. Let's take a soft breath now and look back at the path we've just followed. This quiet trail through flickering light and flickering feeling. We began with a lullaby. Twinkle, twinkle, little star. A song so familiar it lives in our bones. Not just words and melody, but the emotion wrapped inside. The comfort of rhythm, the wonder of the unknown, the gentle asking of a question we never quite outgrow. What are you? From there, we wandered through art and poetry. How a shimmer in the sky becomes a metaphor for love, or longing, or memory. How we take that irregular flash and turn it into meaning, into mood, into something almost sacred. We looked inward too, at how your eyes and mind interpret the flicker. Not as a cold calculation, but as a living moment, one shaped by biology and emotion, by attention and mood. A reminder that what we see is always touched by how we feel. Then we looked outward, across cultures and centuries, to people who didn't see twinkling stars as physical objects, but as spirits, ancestors, messages from the beyond. To those who read the flicker as a whisper from the sky, not just a scattering of light. Their stories remind us that science doesn't erase wonder, it grows alongside it, like branches from the same tree. And we paused with the ancient sky watchers, Babylonian priests, Egyptian stargazers, Greek philosophers, and medieval scholars, who study the flicker with reverence and intent. They didn't need formulas to feel the importance of that glow. They trusted their eyes, their patterns, their intuition. And from those patient nights, entire systems of thought were born. Finally, we return to the present, to you, sitting quietly beneath the stars, maybe with someone beside you, maybe alone. And we saw how the twinkle speaks not just to curiosity but to comfort, how it has a way of appearing when you need it most, not as an answer but as a companion. Because in the end, the most beautiful thing about twinkling stars might be this: they notice you. It's easy to imagine we're just watching the sky, that we're the observers and the stars are passive. But twinkling complicates that. It makes the stars feel responsive, present, like the sky isn't just something we gaze into, but something that gazes back. When you step outside and look up at that shifting, shimmering blanket of night, you're not just seeing physics, you're seeing a mirror. One that reflects your breath, your warmth, your attention. The twinkle, after all, is shaped by your world, by the air above your head, the weather of your evening, even the stillness of your mood. And so the stars flicker, not just with light, but with presence, a soft pulse of connection, a breath matched by your own, a slow rhythm that says, "You're here. I see you." It's not magic, it's not myth, but it feels like both. And maybe that's enough. So tonight, as you drift into rest, let that flicker stay with you. Let it shimmer behind your eyes. Let it soften your thoughts. Because somewhere up there, far beyond the noise, beyond the city, beyond the years, light is still arriving. Light that began its journey long ago. Light that twinkles now, just for you. And the night sky, in its quiet way, is watching back. Let's begin gently. We've been talking about starlight, how it flickers, how it stirs emotion, how it moves through our atmosphere like a traveller meeting the wind. But now we'll pause that visual image and look closer, much closer. Let's look at the light itself. Starlight, like all light, is a strange and beautiful thing. At first glance it might seem simple, just brightness travelling through space. But light, when examined deeply, is not so easily defined. It behaves as if it were two things at once, a wave and a particle. This is not just poetic metaphor, it's a deep truth of physics. Light is made of tiny packets of energy called photons. These photons can act like particles, discrete, countable things like grains of sand, but they also behave like waves, rippling, interfering, spreading out and bending in ways particles never could. It's as if a pebble could ripple across a pond, and also be the ripple itself. This wave-particle duality is one of the most mysterious concepts in all of science. Not because it's unclear, we know how it behaves, but because it defies our usual categories. It asks us to hold two ideas at once. That light can bounce like a ball and bend like a current. That it can arrive in sudden bursts, but also travel as overlapping waves. So when you see a star twinkle, you're seeing this dual nature in action. The photons that left a distant star long ago are flying toward your eye, not just in a straight line, but along paths shaped by the waves they ride. These wavefronts are smooth in space, until they reach the churning sea of Earth's atmosphere, and that's where the dance begins. Each photon is bent slightly by changes in the air, by warmth, by pressure, by the invisible turbulence of rising and falling thermal pockets. As the wavefront of starlight hits these pockets, it becomes uneven, like a smooth ripple suddenly crossing choppy water, and those distortions, while small, scatter the photons ever so slightly. Not enough to stop them from reaching you, but enough to cause that flicker, that twinkle. In a way, twinkling is how we notice light's wave nature. Without it, starlight would reach us uninterrupted, a point of steady illumination. But with it, we see light responding to its environment, bending, stretching, wobbling, still arriving, but changed along the way. And that's not all. Photons, those tiny packets of energy, also interact with the molecules of the air. Occasionally they bounce, or scatter, or slow down just slightly before moving on. These interactions are quantum in nature, meaning they're guided not by strict rules but by probabilities. Where will a photon go? Which path will it take through a patch of uneven air? The answer isn't fixed. It's a matter of likelihood. And what you see, what your eye captures as a star's soft shimmer, is the result of many photons, each following slightly different journeys, each shaped by chance, and air and motion. That's what makes twinkling feel so alive. Because it is. It's not just a signal bouncing off a distant object. It's a moment created from countless interactions between energy and air, between order and chaos, between a star's steady light and the restless sky it must pass through. And then finally that light reaches you, one photon at a time, one ripple at a time, filtered through motion, arriving as meaning. So the next time you look up and see a star flicker, remember, what you're really seeing is the complexity of clarity, a point of light shaped by the structure of the universe, something that is both wave and particle, old and immediate, distant and here. It's not just a twinkle, it's a quantum whisper, and it travelled light years just to reach your eyes. Let's now follow the light just a bit further, into the heart of how it bends, blurs and breaks into colour. If you've ever placed a straw in a glass of water and noticed it looked oddly bent, you've seen refraction at work. Light changes direction when it passes between materials with different densities, like air to water or warm air to cool air. It doesn't crash or bounce, it slides and shifts, gracefully, predictably, and beautifully. When starlight enters Earth's atmosphere, it doesn't encounter one single density, but many. Layers upon layers of air, each with their own temperature and pressure. That means light doesn't just bend once, it bends again and again and again, each time slightly, but collectively enough to send a beam off its original path. This continuous cumulative bending causes the star's image to dance. This is refraction, and it's the reason stars twinkle. But that's not all that's happening. Because light is a wave, it can also interfere with itself, something called diffraction. Imagine waves at the beach passing through a narrow gap between rocks. They spread out on the other side, creating ripples that curve and sometimes overlap in complex patterns. Light does that too. When it passes through small openings or edges, like between particles of dust or moisture in the air, it can diffract, causing ripples and shifts in brightness. These subtle overlaps add to the shimmer. A star may momentarily appear brighter, or split into halos, or briefly lose its edge. Now blend these two together, refraction and diffraction, and you begin to see how starlight becomes a shimmering living thing. It bends and scatters, interferes and warps. It's not chaos, it's complexity, an optical ballet. And then comes the colour. If you've watched a bright star low on the horizon, you may have seen it flicker in different hues. Red, blue, green, back to white. This isn't imagination, it's dispersion. Dispersion is what happens when different wavelengths of light refract by different amounts. Blue light, which has shorter wavelengths, bends more than red light, which has longer ones. So when starlight passes through uneven, shifting air, its colours separate momentarily, causing you to glimpse flashes of violet, yellow, emerald. Not like a rainbow laid out in order, but like tiny sparks of spectrum fluttering from the same flame. It's like nature's own stained glass window, one that reshapes itself constantly with every breath of wind. All of this is governed by principles of atmospheric optics, a field that explains how light interacts with the sky. The same physics that gives us rainbows, halos around the moon, or sundogs in the cold is also responsible for the twinkle of a star. The air becomes a lens, fluid, moving, alive. There's even a formula known as Snell's law that describes how much light bends when it passes from one medium to another. It's often introduced in physics classrooms with rulers, angles and lasers pointed at glass blocks. But out here, under the stars, it plays out invisibly, billions of times over. Each time a photon encounters a new patch of air, it obeys that ancient rule, quietly, reliably. And all those tiny shifts, the fractions of degrees, the flickers of colour, the blur of edges, combine to create something we call twinkle. But underneath, it's a symphony of physics. You don't need to memorise the math to feel the magic. You just need to know it's there. That every flicker you see is the result of light-obeying laws older than memory, shaped by air that moves with the rhythm of the earth. So when you see a star blink or shimmer, you're not seeing something wrong. You're seeing light travel as it always has, through distortion, through difference, through beauty. A flicker, a wave, a bend, a dance, all born in the air between you and the sky. Now that we've looked at how light behaves, let's return to the sky itself, the atmosphere that sculpts each flicker and flash. You can think of the atmosphere as a quilt of shifting air sewn from threads of warmth and cold, pressure and moisture. But it isn't a calm, motionless blanket. It breathes, it churns, it tumbles inward and outward in waves and folds. And at the heart of that movement is something called turbulence. Turbulence is what happens when air stops flowing smoothly and begins to twist and stir. Instead of moving like a river, it becomes more like a pot of simmering water, rising in places, falling in others, bubbling unpredictably. This is especially true near the Earth's surface, where the warmth of buildings, roads and fields rises into the cooler air above. The boundary between ground and sky becomes restless, and that restlessness doesn't stop a few meters up. It continues in layers, sometimes dozens of them, each with its own temperature, its own speed, its own motion. As night falls, these layers start shifting like transparent tectonic plates, colliding and parting silently overhead. Within these layers are thermal cells, pockets of rising warm air and sinking cool air. These cells are constantly in motion, like bubbles in a simmering soup. They aren't visible, but you've likely felt them. If you've ever watched a hot road shimmer on a summer day, or seen the air wobble above a grill, you've seen these cells at work. Now imagine those same rising and falling cells stretched across miles of atmosphere. And imagine starlight, pure, narrow, steady, trying to pass through all of them on its way to your eyes. Every time the starlight passes through one of these thermal pockets, it bends just a little. Not in the same direction, not predictably. One cell might push the light slightly upward, another slightly down. One might slow it, one might scatter it. The result is a shimmering, dancing, ever-changing path. This is the essence of scintillation, the technical term for twinkling. It comes from a Latin word meaning to spark or to glitter, and though the name sounds delicate, the physics is anything but simple. Scintillation is the chaotic interference of light caused by turbulent cells in the air. It's why stars seem to flicker and pulse, even though their light is perfectly steady when it leaves them. And here's something lovely. No two stars twinkle the same way, because the atmosphere is always changing, and because each star's light enters it at a different angle, the path from sky to eye is unique for each one. A star near the horizon might shimmer with fast, sharp pulses. A star high overhead might glow more gently, with a soft, slow rhythm. Even the same star will twinkle differently from 1 hour to the next, one season to the next. The twinkle, then, is a fingerprint of the sky above you in that exact moment. A signature of temperature, wind, and invisible motion. And if you could freeze time and look at the starlight just as it passed through the upper atmosphere, you'd see it waver, not in long, slow waves, but in tiny, jittery bursts, like light trying to find its footing across a shifting floor. Astronomers sometimes describe this as blurring or jittering, but for the stargazer, it's more poetic. A reminder that even the most constant things in the universe can appear to waver, simply because the world around us is alive with movement. So the next time you watch a star dance in the sky, remember, you're seeing the breath of Earth in real time. You're watching warmth rise and fall. You're watching invisible rivers of air stretch and fold and swirl between you and the night. And you're watching light respond, not by fading, but by flickering, by adapting, by shimmering its way into view. If you've ever looked through a telescope on a calm, crisp night and marvelled at the clarity of a distant star, or stared in frustration as everything wobbled and blurred, you've already experienced what astronomers call seeing. It's a simple word, but in astronomy, seeing refers to something very specific: the steadiness and sharpness of the night sky as viewed through Earth's atmosphere. Good seeing means the stars appear steady, their edges crisp, their details clear. Bad seeing. The stars shimmer uncontrollably, dance in and out of focus and blur like candle flames in a drafty room. The cause, as we now know, is turbulence. The very same pockets of rising and falling air, the thermal cells and moving layers we just explored, are what determine whether a night of stargazing will feel like slicing through crystal or staring through rippling glass. Professional astronomers have learned to rate the sky using seeing conditions, often measured in arcseconds, a unit of angular size. It's a way of asking, how much does a pinpoint of light spread out or blur due to the atmosphere? On a perfect night in the best locations on Earth, say the summit of Mauna Kea in Hawaii, or the Atacama Desert in Chile, seeing might be around 0.4 arcseconds. That's astonishingly clear. On an average night closer to sea level, especially near cities, you might be dealing with 2 or 3 arcseconds, or worse. And those numbers matter. At 0.4 arcseconds, you might resolve the tiny gap between a double star. 2 stars so close together, they appear as one without ideal conditions. At 3 arcseconds, that gap is lost. The stars blur into a single pulsing blob. For amateur astronomers, seeing becomes a kind of weather, not about clouds or rain, but about clarity. The sky may look clear, But if the air is unstable, the stars will still shimmer too wildly to allow for crisp viewing. You might hear an observer say, "The transparency was good, but the seeing was poor." That means the sky was cloudless, but the atmosphere above was too chaotic for precise imaging. Cities unfortunately add to the problem. Urban heat islands, where buildings and pavement radiate warmth into the air, create extra turbulence near the surface. So even on a cool night, the air above a city might ripple and wobble more than it does in the countryside. And then there's the jet stream, a high-altitude river of fast-moving air that snakes its way around the globe. When it passes overhead, it can wreak havoc on starlight. Entire observatories watch its path, planning observations around it like sailors avoiding rough seas. There's something humbling about all of this. Even with million-dollar telescopes, even with precise instruments and polished glass, a single gust of high-altitude wind can blur a star that left its home thousands of years ago. But astronomers don't despair. They adapt. They build telescopes in remote, stable places. They use adaptive optics, which we explored earlier, technologies that bend mirrors in real time to cancel out the wobble. And sometimes they simply wait. Because eventually the air calms, the sky steadies, and the stars return to their sharper selves. And for the rest of us, we learn to embrace the dance. Because while bad seeing can frustrate those chasing detail, it also enhances something else: atmosphere. There's a quiet beauty to watching stars flicker wildly on a summer night, to seeing colours flare, to watching a planet swim like a marble through waves of soft distortion. It may not be precise, but it feels alive. In that moment, the stars don't just shine. They shimmer with story, with breath, with warmth, with movement. It's the sky not as a window, but as a living veil. And your eye, even without measurements or equipment, becomes a participant in that motion. So next time you tilt your head toward the night and see stars wavering slightly, don't worry, it's not broken, it's breathing. And tonight the sky's exhaling a little more than usual. Let's linger now at the edge of perception, where starlight bends not just gently but strangely, where the familiar shimmer of twinkling deepens into something more surreal. Because sometimes stars don't just flicker, they shift, they warp, they double. You've probably seen this without even realizing it. A star near the horizon might seem stretched or displaced. A planet may waver like it's underwater. In desert air or over a sun-warmed road, lights appear to float or ripple or fracture. These illusions belong to a broader family of phenomena known as atmospheric lensing. And like all illusions, they begin with truth, then bend. Atmospheric lensing is simply what happens when light is curved on its journey to you, not by a mirror or a piece of glass, but by the air itself. Earth's atmosphere, with all its gradients and motion, becomes a lens. Not a perfect one, but a dynamic, living one. Unlike a camera lens that's polished and still, the atmosphere is uneven, restless, always changing shape. When light from a star enters this wobbly lens, especially when the star is low in the sky, it passes through far more atmosphere than when it's overhead. The longer the path through dense air, the more chances for distortion. Imagine looking through a swimming pool where the water is moving. Waves rippling the surface, warm currents below. If you were to look at a coin resting on the pool's floor, you'd see it shift and warp as the water moves. You'd know the coin isn't moving, but your eye would insist otherwise. Stars behave just like that. The light remains constant, but the atmosphere makes it dance. One of the most dramatic effects is a kind of mirage. You may think of mirages as tricks of the desert, an illusion of water that vanishes as you approach. But in the sky, a similar effect can occur with stars and planets. When layers of warm and cool air form a strong boundary, like just above a road or the ocean at sunset, light bends sharply enough to create duplicate images. A star might appear to hover or elongate. You might see it blur into a short streak, and sometimes, very briefly, it splits in two. These are called inferior mirages, when the duplicate appears below the real image, or superior mirages, when it floats above. They're not hallucinations, they're refracted reality. You're seeing real light, just reshaped. There's even a rare and poetic twist called the green flash. Just as the sun sets, under perfect atmospheric conditions, the upper rim of the sun can briefly glow green. It's not a myth. It's caused by dispersion and refraction, the same physics we've discussed, amplified by layers of calm, stable air. For a second or two, the sky whispers in emerald. And through all of this, it's important to remember, these illusions aren't failures of your eye or failures of nature. They are signatures of how much is happening between the source of light and the person seeing it. They remind us that light is patient, but not immune. That as it travels across the cold vastness of space, it can still be softened, shaped, and sculpted by just a few dozen miles of warm air above Earth. Of course, not all lensing is caused by atmosphere. There's another kind, gravitational lensing, where massive objects like galaxies and black holes curve the very fabric of space-time, bending light on a cosmic scale. But that's a story for another part of the night. Here, beneath the sky we know, it's the atmosphere that performs the magic. So next time you see a star shimmer oddly, or a planet stretch or float near the horizon, let the illusion comfort you. Let it remind you that even the most straightforward path, light to eye, is full of wonder. That even the sky, with all its quiet repetition, still has surprises to offer. The twinkle is only the beginning. Sometimes the light doesn't just flicker, sometimes it doubles. Sometimes it disappears and reappears, like a memory coming into focus. And sometimes, for a blink, it flashes green before fading into night. Now let's climb, up past the rooftops and the tree lines, beyond the buzz of cities and the veil of low-hanging clouds. Let's rise to where the air thins and the stars begin to steady. Because if twinkling begins in the atmosphere, then one way to escape it is to go above it. This is why observatories seek altitude, not for the view, not for the drama, but for the calm. High atop volcanic ridges, desert mountains, and frozen plateaus sit some of the clearest eyes we've ever built. The great observatories of the world. Places like Mauna Kea in Hawaii, the Atacama Plateau in Chile, and La Palma in the Canary Islands. These summits weren't chosen at random. They were selected because they sit above much of the atmosphere's most turbulent layers. Down below, warm air from cities and oceans stirs the sky like soup. But up here, the air is colder, thinner, and more stable. Fewer heat currents rise, less moisture floats, and the light that reaches these peaks, though still bent a little, is far more pristine. Astronomers call this pursuit getting above the seeing. They know they can't eliminate twinkling altogether from Earth's surface, but they can minimise it. And the higher you go, the better your chances. Some observatories go further still, not just climbing mountains, but rising with balloons. These balloon-borne telescopes drift to the very edge of space, lifted by helium, floating at altitudes of 30 kilometres or more. Up there, 99% of the atmosphere is beneath them. The sky is almost black. The stars no longer twinkle, and yet the instruments remain tethered to Earth, still a part of this planet just at its edge. Projects like Boomerang and Blast, balloon-borne large aperture submillimeter telescope, have used these near-space platforms to peer into the early universe, mapping cosmic microwave background radiation and the birthplaces of galaxies, all while escaping the flicker of the air below. There's something poetic in that, reaching for stillness by letting go. Letting a balloon drift upward until the star stops shifting, until the air grows so thin that light can pass through undisturbed. No longer warped, no longer scattered, just clean, quiet brilliance. And of course, above even that, in the inky realm of orbit, lie the space telescopes, Hubble, Webb and others. We've already touched on them, but it's worth remembering that they too began on the ground, designed by hands, dreamed by eyes that first saw stars through wavering air and wondered what might be possible without it. That's the thread connecting it all, curiosity shaped by distortion. If stars had never twinkled, would we have tried to climb above the twinkle? Would we have sent balloons and mirrors and dreams into the stratosphere? Perhaps not. Sometimes the imperfections are what guide us. Back on the ground, we're left with our own kind of magic, watching the stars flicker softly above the horizon, knowing that somewhere high above they shimmer less, but shine all the same. Altitude is a filter. It doesn't change the stars, only how we meet them. So next time you see a mountain telescope in a photograph, or read about a telescope hanging beneath a balloon, know that it's part of the same story you live when you look up from your backyard. The same photons, the same atmosphere, just different places on the path. Some of us watch the twinkle, some try to rise above it, and both are part of the wonder. Take a moment and picture the sky not as empty space but as a living body. It moves, it inhales, it exhales. The air above you is not still. Even on a quiet night it is flowing, curling, stretching. It has rhythm, it has pulse. And the twinkle of stars? That's one way we see it breathe. You might not hear it, but the atmosphere breathes in cycles. Every day, as sunlight warms the land, the oceans, and even the sidewalks of our cities, the air begins to rise. Not all at once, but in patches, in great invisible columns, like slow steam from the whole surface of the earth. Warm air rises, cool air falls. This creates the diurnal, or daily cycles of atmospheric motion. By late afternoon, this motion reaches a kind of crescendo. The surface of the earth is warmest. The air is most unstable. If you tried to observe a star through a telescope at this time, right before sunset or just after, the image would likely ripple and blur. The twinkling would be fast, irregular, sharp. But after the sun sets, something happens. The earth begins to cool, the heat lifts away, the thermal plumes relax, the atmosphere becomes more layered, more stratified, not still, but steadier, and starlight responds. On good nights you'll notice that the twinkling slows as the hours pass. The flickering that was frantic at twilight grows softer, smoother, like a breath moving from tension into sleep. This is one way the planet tells time, not in numbers, but in shimmer. Astronomers know this. They plan their observations accordingly. The best seeing conditions are often found in the calmest part of the night, between midnight and dawn, when the earth has fully exhaled the heat of the day and settled into cooler, quieter breathing. It's easy to forget living on the ground that we're always surrounded by this motion. The wind at your skin is only the outermost ripple. Above it, layers upon layers are drifting in silence. Some of these flows are wide and slow, like rivers of air. Others are local and fast, like whirlpools or drafts, and all of them affect the way starlight arrives. In this way, twinkling becomes more than a curiosity. It's a diagnostic tool, a visible symptom of invisible motion. Like the flutter of leaves tells you something about the wind, the shimmer of a star tells you something about the sky itself. There's a kind of poetry to this. The light of a star, born in nuclear fusion, travelling for centuries, spends only the last fraction of a second dancing through Earth's breath. And yet that final moment is what determines how you see it. Not because the star has changed, but because we have. Our atmosphere is a lens in motion. It's not just a barrier, but a filter. Colouring, shifting, shaping what passes through. And though we often think of it as an obstacle to clear viewing, it's also a gift. Without it, we wouldn't see stars twinkle at all. Their light would be steady, brilliant, but also less alive. It's the atmosphere that gives the stars their flicker, their pulse. It's the Earth's breath that makes the sky shimmer like water. So next time you find yourself watching a star, notice its rhythm. Is it flickering fast, slow? Is it coloured, sharp, or soft? What you're seeing is the planet's condition, its warmth, its restlessness, its quiet. You're watching the pulse of the world measured not in seconds but in shimmer, and as the night deepens and the air calms and the stars settle into their gentle shine, you'll feel it too, the stillness that comes after breath, the pause between motions, the hush between pulses. The earth is breathing, and the stars are listening. Let's go even deeper now, beyond the atmosphere, beyond heat and turbulence. Let's follow the light itself into the strange quiet terrain of the quantum world, because while twinkling begins with air and motion, it is made possible by the light's own mysterious nature. And to understand why starlight twinkles the way it does, we must understand how that light travels at all. It begins with a photon, a single packet of energy emitted from the heart of a star. That photon doesn't move like a tiny marble through space. It doesn't follow a clean, predictable line. Instead, quantum physics tells us that it travels as a probability, a wave of possibilities. It can take many paths, and until it arrives, its exact course is not certain. This is the essence of quantum mechanics. At its smallest scales, nature is not fixed, but fuzzy. Light behaves not as a single answer, but as a cloud of outcomes. When a photon travels from a star to your eye, it doesn't just choose one route, it explores all possible routes simultaneously. This is called the path integral approach. It was made famous by physicist Richard Feynman, who described light's journey not as a line, but as a sum over histories. Every potential path a photon could take is considered, with each path contributing to the final result in a way that depends on its length, its speed, and how it interferes with others. It's as though the photon is gently weighing every possibility, every detour, every ripple in the atmosphere, and choosing its final direction based on the whole landscape of what could have been. And what's beautiful is that, while this might sound like chaos, it leads to precision. Interference among all these paths, constructive and destructive, produces the clear patterns we see. The rings of a diffraction pattern, the brightness of a star, even the shimmer of its twinkle. And when the atmosphere intervenes, when turbulence adds little changes in the path length, when warm and cold air distort the options, it shifts the balance. It tips the scale from smooth to scattered, from steady to flickering. So the twinkle you see in a star is not just the bending of light, it's the remapping of probabilities. It's quantum math unfolding in real time, filtered through warm air and reaching your eye as a shimmer. There's a quiet elegance in this. The turbulence of the sky adds randomness. The quantum nature of light embraces it. Together they create twinkling, not as an error, but as a collaboration. And somehow, within all that complexity, something steady emerges. Because here's the paradox, the twinkle feels random. It looks chaotic. But the light still arrives. Star after star, night after night, across years and centuries, the light continues to find its way through a noisy, shifting world. That is perhaps the greatest miracle of all, that something as delicate as starlight can survive millions of years in transit, navigate a sea of quantum uncertainty, pass through a breathing, tumbling atmosphere, and still shimmer with beauty as it reaches you. It reminds us that randomness doesn't mean disorder, that fuzziness can still lead to form, that chance, when repeated across great numbers, can shape clarity. So the next time you watch a star twinkle, think of this. You're watching a pattern emerge from possibility. You're seeing the calm that lives inside chaos, the stillness hidden in the noise. Light didn't travel one path. It travelled all of them, and it found you anyway. So here we are, having followed a flicker across disciplines, across scales, across time, from wave to particle, from the warm breath of the earth to the quiet math of quantum paths, from ancient sky watchers to mountaintop telescopes, and all of it, contained in the single shimmer of a distant star. Now let's gently bring that story back to where it began, to the air above your head. The twinkling you see when you look up isn't just about the stars, it's about the space between, about what happens in the last fraction of a second before starlight touches your eye. That twinkle is a signature of our world. It tells us that the air isn't empty, it's layered and living, that it holds warmth and coolness, motion and pause, that it flows in rivers, swirls in eddies, and breathes in long, slow cycles. And when starlight passes through this living medium, it carries the story with it. Each flicker is a whisper of temperature, each shift in brightness, a trace of pressure, each moment of sparkle, a sign that the sky is moving, even when we cannot feel it. Atmospheric scientists use this light as a diagnostic tool. By measuring how much starlight bends, distorts, or dances, they can map the structure of the upper atmosphere. They can infer wind speeds at altitude, temperature gradients, and turbulence profiles. Even weather satellites and missile defense systems sometimes rely on understanding how starlight moves through air. So in a sense, when you look at a twinkling star, you're seeing more than a light. You're seeing a measurement, a reading of the atmosphere, written in photons and read by your eyes. But you don't need equations to appreciate that. All you need is a moment of stillness. Look up and notice how no two stars flicker quite the same. Some pulse like distant signals, others shimmer in place like candles, some seem to jump slightly like eyes trying to focus, and then you realise each twinkle is shaped by the sky above you, right now. It's different from what someone else sees 1,000 miles away, or even 10 minutes later. The atmosphere has changed, and so the message of the stars has changed too. It's like watching the same sentence whispered through different winds. The meaning stays, but the rhythm shifts. This is what makes twinkling so quietly profound. It reminds us that we don't just live under the sky, we live within it. We breathe the same air that bends the light. We're part of the conditions that shape the view. You could think of the twinkle as a kind of weather report, delicate, beautiful and immediate. Or you could think of it as a kind of connection, a way the Earth and the cosmos meet, a brief interaction between star and air and eye. Either way, it is not static. It is not a flaw. It is a message. So the next time you look up and see a star waver ever so slightly, let that be your reminder. The sky is not still. And neither are you. We are moving, breathing, changing. And the light that reaches us carries all of that in its quiet shimmer. It is more than brightness. It is a story of the air, a flicker of what lies between. Let's go back, not to the beginning of the universe, but to the beginning of your memory. Do you remember the first time you really noticed a star? Not just glanced at the night sky because it was there, but looked, paused, let your eyes linger on a single, flickering point of light. Maybe it was from a backyard or a campfire clearing. Maybe through a car window on a long ride home. Maybe through the fog of sleepiness on a childhood night when you were supposed to be in bed but weren't quite ready to close your eyes. It probably wasn't a big moment, not marked by fanfare. But something about it stuck. That's how it is with stars. Their magic lies in the quiet. They don't demand your attention, they simply offer it, patiently, every night. The first star you noticed might not have even been the brightest. It might have been alone in the sky, peeking through clouds or glowing low near the horizon. What drew your eye may have been its shimmer, a pulse that seemed to say, "I'm here," a tiny flicker that stood out in the stillness. Or maybe you just remember how it felt to look at something so far away and feel something shift inside your chest. Children often find stars before they understand them, before they've heard the word light year or learned about fusion or parallax. Long before they know what twinkling is, they know what it does. It captures them, calms them, lights a quiet sense of wonder. There's a reason we wrap stars into bedtime, into lullabies. into nightlights shaped like constellations. There's something in that small, steady flicker that soothes, that signals in some gentle ancient way you're not alone in the dark, and that first noticing, that first little moment of stillness, it becomes a thread. Years pass, seasons change. We grow taller, busier, more full of knowing. But often, when we look back, we can trace our quiet fascination to that one early evening, that first glimpse that asked no questions, offered no answers, just presence, just light, just something up there that felt steady when everything else was still in motion. For some, that moment leads to questions. What is that light? How far is it? Why does it flicker? For others, it leads to stories. That star is someone watching. That one is a guide. That one makes wishes come true. And for many, it leads simply to comfort. The world gets noisier as we grow, but the stars stay quiet. And every now and then, we return to that early moment, not through memory, but through feeling. Standing outside on a late evening, you catch a glimpse of a single flickering light, and suddenly, the years fall away. You're small again, but not lost. You're held. That's what twinkling can do. It doesn't just mark the physics of our atmosphere. It marks something in us, a softness, a stillness, a shared knowing that starts early and never quite leaves. So tonight, if the sky is clear, maybe look up again, not to study or name or measure, just to remember, to see if you can feel what you felt the first time you noticed a star, because it's still there, still flickering, still waiting. Long before we had GPS satellites blinking above us, the stars were our guides. They shimmered in fixed places, returning night after night, season after season. And while their flickering may have seemed like poetry to the poet, to the traveller, it was something far more practical. It was a compass, a calendar, a clock ticking softly in the dark. Ancient civilizations built entire systems of orientation around the night sky. They watched not just where the stars rose, but when. Which ones appeared first after sunset? Which ones twinkled low over the horizon before the dawn? The flicker, the brightness, the colour, all became part of a code, and they learned to read it. The Polynesians, for example, are still known as some of the most masterful navigators in history. Long before compasses or sextants, they crossed vast stretches of the Pacific Ocean in open canoes, guided only by the wind, the waves, and the stars. They memorized sky maps not drawn on paper, but carried in the mind. Constellations rose and set in known sequences. Twinkling stars near the horizon could tell them the direction of land, or hint at incoming weather. To these voyagers, the night sky was not abstract. It was intimate, alive, a familiar ceiling above a moving world. In ancient Mesopotamia, star charts were carved into clay. Babylonians used the flicker and brightness of stars to mark the timing of events, planting, harvesting, rituals. The position of a twinkling star near the horizon could tell them when seasons were shifting, long before any calendar was written. In Egypt, Sirius, the brightest star in the night sky, was deeply tied to the Nile. When it began to twinkle again in the early morning sky after a period of absence, it signalled the river's annual flooding. Life itself moved with the rhythm of a distant shimmer. And in ancient Greece, stars helped mark hours in the night. Before mechanical clocks, time was felt through movement, of shadows, of constellations. A twinkling star that reached its peak at midnight could serve as a skybound hour hand. These early timekeepers learned to track the heavens as if they were gears on a great cosmic watch. Even now, stargazers still use twinkling to orient themselves. A flickering star near the horizon tells you you're looking through more atmosphere, that you're likely facing west or east. The North Star doesn't twinkle much at all. It hangs steady above the axis of our planet, its glow unwavering. That steadiness makes it a natural anchor point in the sky. Sailors for centuries turned toward it, trusting it to hold true even as the ocean shifted beneath them, and the flicker itself, once feared as a flaw, became a feature. It signalled elevation, air quality, distance. An experienced observer could learn to distinguish stars from planets at a glance. Stars twinkle, planets usually don't. All of this knowledge, all of this quiet wisdom, began not in books or laboratories, but in human attention. In people who stood under the stars night after night, watching the light and learning what it meant. And always there was the twinkle, sometimes subtle, sometimes dramatic, but always speaking, always pointing, always guiding someone across water, across sand, across time. So next time you find yourself outside in the hush of night, try looking up not for beauty alone, but for orientation. Ask yourself, where am I? What direction does that twinkle point toward? What might it have meant to someone standing here 1,000 years ago? The stars above you haven't changed, but how you see them just might. Now let's stay grounded for a moment. Not in cities or ships, but in the wide fields and quiet hills where weather is not just background noise but everything. For most of human history, people didn't check the forecast. They read it. In the colour of the sunrise, in the smell of the wind, and often in the twinkle of the stars. Yes, twinkling has long been more than a scientific curiosity or poetic metaphor. It has been a form of weather prediction, a nighttime whisper from the sky. Farmers, for example, learned to trust the shimmer of certain stars as a sign of approaching change. When the air was especially unstable, when warm and cold pockets danced more than usual, the stars would flicker faster, sometimes even appearing to flash with hints of red or green. That erratic twinkle meant the atmosphere was unsettled, and when the sky was clear but the stars twinkled furiously low on the horizon, it could mean wind was rising. For a farmer who needed to protect crops or cover a well, that was precious information. Sailors, too, became deeply attuned to the sky. Before barometers and weather buoys, they would watch the stars from the deck of a ship. A fast, sharp flicker could mean a storm front was nearing. A sudden shift in how the stars danced could mean the jet stream above was shifting. Wind at sea is invisible, but its signs often live in the air above, where starlight has to pass. And so, across generations, traditions formed. In coastal villages and mountain communities, people passed down sayings like, "When the stars wink hard, the wind won't be far," or "Steady stars mean steady skies." It wasn't always exact, but it wasn't random either. They were noticing real phenomena, subtle but dependable clues etched in the behaviour of light. In some cultures, the connection went even further. Twinkling stars weren't just weather signs, they were spirits, or deities sending signals. In parts of the Andes, for example, the brightness and flicker rate of specific stars were used to anticipate rainfall for planting. The observations were woven into festivals, prayers and planning. Science and spirit walked hand in hand, and even today some pilots and amateur meteorologists still pay attention. Though we now have satellites, Doppler radar, and complex climate models, there's still a unique kind of knowledge that comes from simply watching. If the stars above are flickering rapidly, there's turbulence somewhere. If they seem steadier than usual, the air may be calm, even if you feel a breeze at the surface. The stars offer a view into the sky's upper stories, places we can't easily touch, but that shape our lives all the same. And the best part, this knowledge doesn't require special tools. Just time, just looking. You could try it tonight if the sky's clear. Step outside after dark. Find a bright star low on the horizon, then one high overhead. Compare their twinkle. Notice if the air feels damp or dry, if the wind is soft or strong. You may begin to see patterns, a rhythm in the flicker that speaks of more than just beauty. Because twinkling is more than the star's voice. It's the voice of the air. And sometimes it's trying to tell you something. A change is coming, or not. You only have to watch quietly to hear it. There's something quietly strange about it, isn't there? You can gaze up at the stars in real life, watching them flicker like candle flames behind a curtain of wind, and you're immediately drawn in by the twinkle. But in dreams, they don't seem to do that. The stars in dreams are often still, steady, silent and luminous, yes, but not dancing, not blinking. Why is that? Let's settle into this gentle curiosity, like we're tracing our fingers across the surface of a still pond. Dreams are painted by the mind. They don't come from the eyes, or the air, or the movement of molecules. In the dreaming world, there's no atmosphere to disrupt the path of starlight. No shifting pockets of warm and cold air to bend photons this way or that. There's only the raw memory of a star, how your mind remembers it, how it decides to show it to you. The stars in dreams are internal. Your brain, when dreaming, is both set designer and lighting technician. It creates the night sky without needing physics to help it along. And when the subconscious mind decides to add stars, it often leaves out the atmospheric interference. Not because it doesn't know about it, but because it doesn't need it. It's reaching for symbolism, not simulation. And here's the other part. The twinkle itself is a perception, not an inherent property of the star. It's not the star that flickers, but our view of it from Earth, filtered through layers of air and refracted by the turbulence above us. When you dream, you bypass that. You skip the atmosphere. You go straight to the source, or rather, to your internal version of the source. In fact, many people who dream of stars report them as strange, steady, even surreal. Enormous pinpoints of clarity, too bright or too perfect. Some recall stars that pulse slowly as if breathing. Others see only one or two glowing like eyes, or companions or memories. Never flickering, never unclear. There's a gentle beauty in this, because while science explains the twinkle, your dreaming brain seeks the meaning. It reaches past the distortion and lifts you into something cleaner, more poetic. In dreams, stars aren't broken by the weather. They're unshaken, and in that clarity, perhaps there's comfort. Now, from a neuroscience perspective, this stillness makes even more sense. Dreams happen mostly in REM sleep. In that phase, your eyes move rapidly behind your lids, but your body is paralysed, and so is much of your sensory input. The thalamus, the brain's sensory gateway, limits incoming external information. Your dream sky isn't being seen by your eyes. It's being assembled by your memory, your emotion, your narrative wiring. And memory doesn't store twinkle. It remembers that there was a star, not how it behaved minute by minute. Twinkle is noise, tiny variations in signal that don't always stick in the brain. So when your dreaming mind needs a star, it retrieves the cleanest, quietest version available. Still, bright, silent, like an old friend waiting just where you left them. This might also explain why stars in dreams feel closer, bigger, more personal. When you dream, there's no atmosphere to remind you that they're impossibly far away. You aren't grounded in physics or distance. You're immersed in feeling. And feelings are close. So the next time you dream of stars, notice their silence, their steadiness. You're seeing them not as they are in the sky, but as they've always been to you deep in the mind where no turbulence can reach them. And maybe that's why in dreams the stars finally hold still. And here's the other part of the mystery, one that feels less like a science lesson and more like a soft whisper from somewhere deep in the folds of your memory. In dreams, your mind often favours clarity over realism. Not always, of course. There are plenty of absurd dream sequences involving flying goats or underwater birthdays. But when it comes to stars, something changes. They become symbols, not points of data. Silent companions glowing above a dream version of a childhood house, or a starry sky stretching above an imagined mountain perfectly still. These stars don't need to twinkle because they're not being filtered through your waking senses. They are emotional constants, glowing ideas. In a way, the stillness of stars in dreams might reflect something we long for in waking life. Constancy, quiet, peace. The twinkle we see with our eyes is an artifact of Earth's breath, but the stars in our sleep are not filtered by wind or weather. They are how your mind holds the idea of a star, not the flickering light itself, but what it means. A point of guidance, a memory, a kind of quiet that doesn't need movement to feel alive. Neuroscience has a few things to say here too. When you dream, particularly during REM sleep, the visual cortex of your brain lights up. You're seeing without seeing. Your eyes are closed, but your mind is projecting images with surprising vividness. However, the inputs are internal, not external. You're not getting real-time data from your retina or optic nerve. That means there's no real starlight and no real atmosphere, just imagination. The flicker, the twinkle, the atmospheric shimmer, all of that depends on physics outside your skull. But dreams don't run on optics. They run on memory, meaning, and mood. Interestingly, people who have lost their sight later in life can still dream in visual images. Their brains remember light, and if they ever stared at the stars when they were younger, those memories can still emerge in sleep. But even then, those remembered stars rarely twinkle. They shine, simply, silently. Maybe it's because the dream world doesn't need distractions. Maybe it's because the twinkle is something we associate with watching, not with feeling. In dreams, we don't always watch, we inhabit. When you dream, the line between you and the star vanishes. You aren't just gazing at something a million light years away. You are there, or it is here. The distance collapses, the atmosphere disappears. The star doesn't need to travel through turbulence to reach you. It's already part of the sky behind your eyes. And maybe, in that silence, the twinkle would be too much, too busy, too awake. Because in dreams, we don't always need reminders that the world is moving. Sometimes we just need something that stays, a star that doesn't flicker, a night sky without wind, a stillness that lets you rest. So the next time you wake up from a dream where the stars looked oddly perfect, oddly still, remember it wasn't a mistake. Your mind was showing you not the sky as it is, but the sky as it feels, a calm, undisturbed canvas for your quietest stories. Not every story about stars is quiet comfort. Sometimes it's quiet loss, because in many places the stars have stopped twinkling, not because the physics has changed, not because the atmosphere is stilled, but because the view is being slowly erased. Step into a city at night and look up. You might see a few of the brightest stars, maybe a planet or two. But the shimmer, the flicker, the soft punctuation of hundreds of tiny lights dancing at the edge of vision, it's gone. This is light pollution, a phrase that sounds gentle, like a little too much brightness. But it's more than that. It's a veil, a fog of artificial glow that hangs over neighbourhoods, shopping centres, roadways and skylines. It drowns out the subtle signals of the cosmos, washing the sky in a pale haze where only the loudest stars survive. The twinkle doesn't vanish all at once. It fades slowly. First, you lose the faintest stars, those tiny whispers of light that twinkle the most, dancing just above the horizon or behind distant trees. Then, the mid-range stars, the ones that stitch the constellations together in ancient memory. And finally, even the brighter stars begin to lose their shimmer, not because they stop twinkling, but because the background becomes too bright to notice. Twinkling is delicate. It needs contrast. It needs darkness. Without it, the magic is still there, but unseen. Some studies suggest that over 80% of the world's population now lives under light-polluted skies. In many urban areas, the Milky Way is no longer visible at all. A river of stars that once flowed overhead is now forgotten by default. The shimmer that once inspired poets, sailors, children it gets dimmed by parking lots and floodlights. And there's more than just beauty at stake. Excessive light disrupts ecosystems. Birds that migrate by starlight become disoriented. Insects circle endlessly around artificial bulbs. Even humans suffer, our circadian rhythms thrown out of sync by glowing nights that confuse the body into thinking it's still day, and emotionally something shifts. Without the stars, the night can feel smaller, less layered. The sky flattens. You might look up and feel something is missing, even if you don't know what. But here's the quiet hope. This is one loss we can reverse. Unlike carbon in the atmosphere or melting ice, light pollution can be undone with a flick of a switch, or the shielding of a bulb. It doesn't take centuries, just care, awareness, the desire to see again what was always there. Communities around the world are working to preserve dark skies. National parks in the US, remote villages in Europe, observatories in South America, these places are creating sanctuaries of starlight. Some have become official dark sky reserves, where outdoor lighting is minimized, directed downward, and timed to serve only when needed. And when the lights are lowered, something extraordinary returns. The stars come back, not just the bright ones, but the whole orchestra. The sparkle, the shimmer, the layered quiet that makes the sky feel infinite again. If you've ever been in a truly dark place, away from cities, under a blanket of deep night, you know the feeling. The sky doesn't just shine, it moves. It flickers with depth, with time, with breath. It reminds you that you're small, but not lost. So wherever you are, maybe try this. If you can, find a patch of night not yet drowned in glow. A backyard with the lights turned off. A rural road. A quiet campsite. Let your eyes adjust. Let the shimmer return. Because the stars haven't stopped twinkling. We've just forgotten how to see them. We've followed the science of twinkling through the atmosphere and memory. But there's another path starlight takes. One that doesn't bend or scatter, but instead slips quietly into human imagination. Through poems, through songs, through the arts that soften knowledge into feeling. Because long before we could explain why stars twinkle, we were moved by the way they did. You've heard the most famous example. Twinkle, twinkle, little star. It's a lullaby almost everyone knows. Simple, repetitive, comforting. But hidden inside that familiar melody is the emotional truth of starlight, an observation turned into a soothing song. The flicker becomes a metaphor for distance, mystery, even magic. Something small and constant in a sky that never quite stops moving. But lullabies are only the beginning. Poets across time have turned to the stars for inspiration, and almost always it's the twinkle that captures them, not the steady glow. Shakespeare called them golden candles in the firmament. In his plays, stars wink and flash, carrying fate, desire, and omens. In Japanese haiku, stars are rarely static. They often spark, flutter, or breathe. Their light described in the language of wind and silence. The twinkle is never just visual, it's emotional texture. And in music, composers have reached for starlight with soft hands. Claude Debussy's pieces ripple like moonlight on water. Chopin's nocturnes carry the hush of a starry room, where twinkling isn't heard directly, but felt between the notes. That same flutter, that same shifting rhythm, a little like a pulse, a little like a memory. Even painters try to capture the shimmer. Van Gogh's Starry Night is perhaps the most famous attempt, a sky that doesn't sit still, where every star glows with motion, swirling in thick, expressive brushstrokes. He wasn't painting what the eye sees. He was painting what the heart feels when it looks up and sees something flicker in the dark. Why does twinkling stir us this way? Perhaps because it reminds us that even light can falter, that even the stars, which we often see as perfect and eternal, have a kind of vulnerability, a quiver, a softness, It makes them feel closer, like us. A steady light is impressive, but a shimmering one is relatable. We see in it our own moods, our uncertainties, our hopes that rise and fall with the wind. A flickering star feels like it's trying, just like we are, holding its place, glowing despite the currents, and so we write about it, sing about it, paint it not as a pinpoint, but as a presence. Modern artists too continue this quiet dialogue with the sky. A minimalist composer might write a piece where a single note fades in and out, twinkling slowly in sound. A photographer might time their shots to catch the precise blur of a distant star, capturing not just the image but the feeling of it trembling. And all of this soft celebration of flickering, light, comes from the same experience you've had, standing under a night sky, watching something shimmer far away and feeling something, not certainty, not information, but wonder. The arts don't try to measure the stars, they try to sit with them, to listen, to echo their language in human form, and in doing so they remind us that science and feeling don't stand apart, that the twinkle of a star is not just an optical phenomenon and not just a metaphor, but both. A real thing that moves the air and a symbol that moves the heart. So the next time a poem mentions stars, or a song seems to carry their rhythm, or a painting swirls like twilight, know that you're witnessing a quiet tradition, a long shared effort to bring the sky a little closer, to make twinkling not just something we see, but something we feel. Now, let's return gently to science, not to equations or instruments, but to the quiet marvel that sometimes, through a flicker, we learn something entirely new. You see, twinkling isn't just a poetic detail or a nuisance to astronomers. Sometimes it reveals secrets. In recent decades, scientists began noticing a particular kind of flicker, one that wasn't caused by our atmosphere, but by something out there. A star would dim ever so slightly, just for a few hours, then return to normal. Not a shimmer, a dip, whisper of absence. And from that subtle pattern of dimming came one of the greatest discoveries of modern astronomy: exoplanets. Planets orbiting stars far beyond our solar system. The method is called transit detection. Imagine a planet passing in front of its star from our point of view. As it crosses, it blocks a tiny fraction of the star's light, sometimes less than 1%. To the human eye, it would be imperceptible. But to a sensitive telescope, it's a clue. That tiny temporary dimming is a cosmic blink. Not random like atmospheric twinkle, but rhythmic, predictable. If it happens again a few nights later, and then again on schedule, astronomers know they've likely found a planet making regular trips around its star. From just that flicker, so soft, so distant, we can learn astonishing things. The planet's size, its orbit, sometimes even the hint of an atmosphere if the light changes colour as it passes through. Think about that for a moment. A small shadow across a distant light tells us that a world is there. Maybe rocky, maybe wet, maybe something like home. And all of it, from flicker to finding, begins with light. It's not so different from how ancient navigators read the stars, but instead of guiding ships, we're guiding understanding, using starlight not as a compass across water, but as a bridge across the void. You could say the stars are still guiding us. Only now they're pointing not to new lands, but to new planets. And it's not only exoplanets. Other flickers have told us of dying stars, spinning pulsars, or black holes feeding invisibly on nearby matter. When a star's light changes, astronomers ask why. Is it wobbling? Spinning? Is something passing in front of it? Or pulling at it from the side? The answers, more often than not, begin with a change in light. A twinkle, a dim, a gentle interruption. It's humbling, isn't it? That something as small as a flicker, something you can see while lying on your back in the grass, can lead to such enormous truths. You don't need to be a scientist to feel this connection. Just imagine it. that when you look at a star and see it dance slightly in the sky, you're witnessing not just the movement of air, but the beginning of a method, a language, a way of learning. And somewhere, a telescope far above the clouds is watching a similar light, waiting for it to flicker in just the right way to say, I have a planet. Starlight carries more than brightness. It carries information. It carries timing. It carries the fingerprint of what lies between us and it. And our job, our quiet joy, is simply to notice, to be patient, to pay attention when the light shifts. Because even the smallest flicker might mean something is there, something new, something distant, something worth knowing. So here we are, beneath the same sky we've always been beneath, the same canopy of light, the same scattered brilliance that ancient hands once traced into constellations. We've explored why stars twinkle, how they help us navigate, what they whisper about weather, how they vanish in our dreams and cities, and how, through those tiny flickers, we find entire worlds beyond our own. And yet, through all that science and story, one thing remains. Stars feel familiar. They are our companions, not loud or demanding, but consistent, quiet, present. The stars have watched over us through every chapter of human life. They were there when the first fires were lit, when ships first left sight of land, when fields were planted, when lullabies were sung. Their light, though changed by air, always returns. They flicker, yes, but they don't leave. A star you saw as a child blinking gently through your bedroom window is likely still there tonight, waiting behind the clouds or just above the rooftops, or rising quietly in the east. Their light may be old, sometimes older than the mountains, older than our species, but it's also new to us each time we see it, because every twinkle is an arrival, a photon's long journey completed, a silent touch across vastness, and over time, the stars become part of how we mark our own story. You remember where you were when you first really saw one. You might recall nights walking home under a handful of them, or moments of quiet when you looked up and found the sky glowing with more than you remembered. They become tied to memory, to emotion, to meaning. We don't always need to explain. Not all companions speak. Some simply shine. And when we let ourselves slow down, to just watch, we begin to understand that their flicker is more than an effect. It's a language, a pulse, the gentle reminder that something impossibly far away can still reach you. Even in cities, even in noise, even when the shimmer is faint, stars remain. Behind the glow, above the turbulence, they hold their place. They don't push their presence. They simply wait for us to notice. And in that noticing, something quiet awakens. Because to watch a star is to sit beside time. It is to be small and still, and somehow okay with that. To accept not knowing everything, but to find peace in the knowing that something enduring watches back. They are not gods, nor messengers, nor answers, but they are here, and perhaps that's enough. So tonight, if you can, look up. Find even one star. Let it twinkle. Let it flicker and fade and brighten again. Let your eyes adjust. Let your breath slow to match its rhythm. You're not alone. You never have been. The stars have always been with you, patient and persistent, twinkling not to distract you, but to remind you that even the smallest glimmer in the night can mean something, and in their company we remember how to wonder, how to rest, how to simply be. And now, let's sit here, just for a little while, beneath the quiet sky, beneath the same stars we've been travelling with this whole time. You don't need to do anything. Just let your thoughts rest. Let your breath slow. Let your eyes soften, even if they're closed. Because tonight, we've walked a long path together. We began with a question. Why do stars twinkle? And like all good questions, it opened into many more. We followed starlight from the heart of a distant sun to the curve of Earth's atmosphere. We saw how that gentle shimmer, so delicate, so familiar, comes not from the stars themselves but from the air we breathe. The warmth of the day, the chill of the night, the movement of wind and weather, all of it weaving and warping the light that finally reaches us. We discovered that twinkling is an illusion, but not a lie. It's a collaboration between distant suns and the living sky above us, a dance between constancy and change. But twinkling was never just a matter of physics. It was a lullaby too, a companion in childhood, a mystery on long drives, a guide for navigators, a whisper of weather, a memory in a dream. It lived in the spaces between science and poetry, in the soft flicker that doesn't quite stay still and doesn't quite need to. We saw how it slipped into lullabies, lit up canvases, moved through Chopin's notes and Van Gogh's strokes. It reminded us that what we observe is not just outside us, but shaped by what we feel. We explored why stars don't twinkle in dreams. Because in dreams, there is no atmosphere, only clarity, memory, imagination. Stars don't need to shimmer there, because they already live inside you, whole and still. And we sat with the truth that not all stars twinkle for everyone anymore. In cities and towns, under layers of artificial light, the shimmer fades, the orchestra dims, but the stars are still there, waiting behind the glow, waiting for darkness to return. And through it all the twinkle stayed with us, not as noise, but as signal. A flicker that sometimes meant weather, sometimes meant comfort, and sometimes meant a planet, quietly crossing the face of a faraway star. We saw how even scientists use twinkling, not just to correct it, but to learn from it, to find new worlds, to read the pulse of the sky, to understand that starlight, while ancient, is never silent. And now, as we prepare to leave this path and slip gently into rest, it's worth pausing once more to notice something. Twinkling is both distraction and direction. It can pull your eye and scatter your thoughts, or it can center you, remind you that something far away is reaching you through every layer of air, every ripple of wind, every restless current. The science and the poetry are not separate, they are the same shimmer. So as you lie back, maybe in bed, maybe just in your mind, imagine the sky above you. Imagine the stars just beginning to appear one by one, some bright, some faint, some steady, some flickering like the breath of a candle in another room. And let it all be enough. No more needing to understand, no more needing to remember every fact. Just the soft knowing that twinkle exists because the world is alive, and so are you. Now let's take a breath together. Slowly in and gently out. No rush. Just let the air move through you like starlight moving through sky. Unhurried, quiet, graceful. Because the sky above us is always moving. We may not feel it, may not see it, but the air dances. The atmosphere breathes. It warms with the sun and exhales into the night. It sighs with the mountains and curls around the edges of clouds. It's in this breath, the breath of the world, that starlight shimmers. And when you breathe now, you join that rhythm. You become part of the flicker. We often think of twinkling as random, as something chaotic and unpredictable. But what if instead we saw it as alive, as something pulsing gently with the rise and fall of the world's own inhale? Try that now. Match your breath to the stars, not to a single twinkle, but to the overall rhythm. The feeling of motion slowed to stillness. Imagine the sky breathing too. Long, deep movements of invisible air, carrying starlight through layers of temperature and time. Inhale, the star brightens. Exhale, the star shimmers. And again. You're not just under the sky. You are in it. The same air that bends the light surrounds you, holds you, moves with your breath. It softens the edges of the night and gives everything that quiet sense of being gently blurred. There's something comforting in that. To know that your body is made to move with the world, that your breath aligns not only with your heartbeat, but with something wider, something stretched across oceans, across mountaintops, across galaxies. And in this soft moment, you may begin to feel a little less separate, less apart from the stars and more like a part of their story. You're not just watching the flicker, you're participating in it. Even now, as you lie still, your body's moving in rhythm, your chest rising and falling, your thoughts drifting like light through air. Nothing forced, nothing held, just breathe, just being. Some nights, it's enough to look up and be still. Other nights, it's enough to simply breathe and know that you are breathing the same air that shapes the stars. And even if clouds cover the sky tonight, or city lights hide the stars from view, the breath continues. The rhythm holds. The twinkle persists behind it all. So breathe with the night. Let it be your companion. Let your inhale feel like a wave coming in from some distant shore of the sky. Let your exhale feel like a leaf falling slowly through moonlight. And if you find yourself drifting off, let it happen like starlight reaching you, quietly, softly, with no need to rush. Because here, beneath the flickering sky, even sleep is part of the rhythm. Now that we're breathing with the night, let's look up again, gently, slowly, as if you're lifting your eyes not just to the sky, but to the question of where you are within it. Not in a grand way, not in a way that needs measuring or labeling or defining, just in the way that acknowledges you are here, you, a small figure resting under a sky full of stars. When you look at a single twinkling light far above, you're seeing something ancient. Light that began its journey long before your day began, long before your city was built, long before your species even had names for the constellations. And now, here it is. This tiny glimmer, this flicker just for you. It passed through cold stretches of space, through the breathing curtain of air that wraps around your world, and finally, through your eyelashes, into your eye, onto your retina, into your brain. A star chose a path, and it led here. That might sound impossibly vast, but the strange truth is, the more you zoom out, the more intimate it starts to feel. You aren't just looking at stars, you're sitting inside the same cosmos, part of it, breathing with it, watching it shimmer from the inside. The vastness isn't something to be afraid of, it's something to feel held by. You don't need to understand every law of physics to be part of this. You don't need to calculate distances or memorize names of galaxies. All you need is this small moment, this breath, this flicker that reminds you, quietly, calmly, that you are alive in something beautiful. You're not at the centre of it all, but you're not outside of it either. You're exactly where you're supposed to be, a witness to the stars, a listener to their slow twinkling language, a mind soft enough to wonder. There's a peaceful kind of humility that comes with stargazing. It doesn't make your worries vanish, it just helps you place them gently in context. That thing you were worrying about earlier, it still matters. But maybe it floats a little now. Maybe it feels smaller, more manageable, under this glowing ceiling of distant suns. You don't need to be big to be meaningful. You don't need to shine to be worthy. You just need to be here, and you are. As you lie there, eyes closed or half open, breath slow, you're participating in something quietly enormous, something ancient and ongoing. The stars twinkle not because they choose to, but because of the air that moves around you, the warmth that rises from the ground, the motion of the living earth. Twinkling is local, it's personal, and in a way, it's a collaboration between something impossibly far away and you. So stay there a little longer. Let the sky be big. Let yourself be small. Not in a diminished way, but in a relieved way. In a grateful way. In the way that says, I don't have to carry everything, I just have to be present. You're not the whole night sky, but you are part of the night, and that is more than enough. What if stillness doesn't mean the absence of movement? What if stillness can live within motion, like a candle holding steady in a breeze, or a thought resting gently in a mind full of drift? That's what stars teach us, if we're quiet enough to listen, because the twinkle we see, those soft shifting glimmers, it isn't a flaw. It's not a failure of light to stay on course. It's the result of a journey, of passage through a world that moves, breathes, shifts, and yet the star itself doesn't flicker. It burns steadily, far away, sending light across empty space without pause. What changes is everything in between, and that in its own gentle way is a lesson. You too can be steady, even if your thoughts flicker, even if your feelings shimmer with uncertainty, even if your path wavers through winds you didn't expect. Stillness isn't perfection, it's permission. It's the quiet confidence to remain present, even when the air around you shifts, even when the world distorts your light for a while. A star's twinkle doesn't make it less of a star. If anything, it reminds us that light can endure, can even shine more beautifully, because it passes through something turbulent. It's easy to forget that, to think we have to be constant, unwavering, brilliant at all times. But nothing in nature works that way. Trees sway, rivers ripple, even stars seen through our sky dance just a little, and yet none of them are any less themselves. So tonight, if your thoughts flicker, let them. If your emotions shift and change shape, let them. If your memories float up and shimmer in and out of view, let them. You are still you, still here, still shining beneath the sky that makes even light tremble slightly. You don't have to resist the flicker. You can rest within it, like a boat that rocks gently on a lake, not lost, just moving with the surface. Stillness is not about stopping. It's about accepting the blur, embracing the shimmer, trusting that your light will make it through, even if it changes shape along the way. Because just like starlight, your presence doesn't vanish when it wavers. It adapts. It glows through distortion. It finds a way. This is what the stars have shown us for thousands of years, not only through telescopes and charts, but in the hush of night, when we pause long enough to notice how they never quite sit still, and yet they're always there. So breathe again. And imagine the twinkling not as a distraction, but as a mirror. Not of your weakness, but of your resilience, of your quiet willingness to exist through the blur, to remain whole even when the world shifts around you, to be like starlight, real, radiant, and patient. And now we've come to the final flicker. The stars are still above you, still twinkling, even if your eyes are closed now, even if the night has deepened around you, even if you've drifted halfway between waking and dreaming. They're still there, quiet, patient, not asking anything from you, just glowing. The science has quieted, the diagrams are folded away, the words are becoming softer now like footsteps fading down a garden path. All that remains is presence, light, air, you. You don't need to remember everything we explored tonight. You don't need to hold on to every fact about refraction, or turbulence, or transit dimming. That knowledge is still there, somewhere, gently tucked into your mind like starlight on a windowsill. It will stay. And if it doesn't, that's okay too. Because what really matters is how you feel beneath the sky. Maybe a little smaller, maybe a little more spacious inside, maybe more connected to something old, something calm, something that twinkles without ever needing your permission. The stars don't wait for silence, but they reward it. And in this silence now, in this soft goodbye, you're not alone. You're sharing this night with others around the world, some looking up from snowy rooftops, others from warm beaches, others from city balconies, with only a few stars peeking through. But they're looking, breathing, wondering. Just like you, the stars have always seen us, and we, when we take the time, see them. So before we part ways for the night, let's sit one last moment with that thought, that even when things blur, even when nothing feels steady, the twinkle reminds us something is reaching you. Light, softened by wind. Time, delivered through air. A shimmer that exists only because the world is alive. And so are you. Let the stars do their quiet work now. Let them twinkle and fade and return again. Let them be your ceiling, your story, your slow goodbye. And whenever you need this feeling again, it'll be waiting. Because the stars are always there. Even when hidden, even when silent, even when you forget. They remember. They shine. They wait. Sleep well now, beneath the flickering sky.